Square roots. When thinking about square roots, we first have to go back and remember what it means to square a number. The product of two equal factors is the square of the number. And this can be seen when looking at an actual square. If we have a square where the side length is 5 units, the area of the square is going to be 25 square units. And this is because the area of a square is the side times the side. So 5 times 5, which is equal to 5 squared, or 5 to the second, is equal to 25. So now the area of this square we know is 49 square units. What is the length of each side of this square? Discuss with your partner or group. How can you relate the last example we just talked about to this one? How can you relate what you know about the area of a square and the formula to help you find the length of that side? So the length of each side is 7 units. This is because if you have a square, it's going to be the area is the side times side. So it's 7 times 7, and that equals 49. So the area of a square is 49 square units. The length of the side is 7 units. The area of a square is found by squaring the length of one side. If we have our square with a side length of s, the formula for the area is s squared. If you know the area and want to find the length of any side, then you will need to use an inverse operation or an opposite operation. So here we have the numbers in the right column of this table are squares of the numbers in the left column. So 1 squared is 1, 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16, and so on and so forth. Now, if you want to undo squaring a number, you must take what we call the square root of the number. The symbol for the square root is called the radical sign, and it looks like this. So the numbers in the left column are the square roots of the numbers in the right column. So for example, if I look at this row in the table, we know that 9 squared is equal to 81, but now if we go backwards, we also know the square root of 81 is equal to 9. When the square root of a number is a whole number, the number is also called a perfect square. So since all of the numbers in the right-hand column have whole numbers for their square roots, this is a list of the first 15 perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. Those are all perfect squares. Now, we can then conclude that the square root of the area is going to equal the length of that side of the square. So here's an example. We're told the area of a square is 100 square units. Since we now know the square root of 100 is equal to 10, the length of any side of that square is 10 units. And this can be verified from our prior knowledge that we know 10 times 10 is equal to 100. So 10 squared is equal to 100. An inverse operation undoes an operation. It returns us to where we started. For example, we know subtraction is the inverse operation to addition. If we add 5 to a number and then subtract 5, we get back to the original number. So let's say you have 2 plus 5 is equal to 7, but then you subtract 5, you get right back to 2. We also know that division is the inverse operation to multiplication. If we multiply a number by 7 and then divide by 7, we get back to the original number. So now let's multiply 2 times 7 equals 14. But then if we divide by 7, we get right back to 2. Inverses have that special property. We will explore an operation that undoes squaring a number. So just to clarify, squaring a number is to multiply that number by itself. So when we say squaring 4, that is multiplying 4 times 4 to get 16. That's why we can do 4 squared is equal to 16. So an inverse of squaring would start with the square, 16, and then return us back to the original number, 4. That operation is defined as taking the square root of a number. That's the inverse of squaring a number. The square root is an inverse to squaring. Again, we have our symbol for the square root is the radical sign. So here we have, given that 4 squared is equal to 16, it follows from the inverse that the square root of 16 equals 4. See how we got back to where we started from. We started with 4 and then we ended up with 4. Performing that operation and then the inverse returned us to where we started. In this case, the square root of 16 being 4 tells us that 4 multiplied by itself equals 16. You can go back and forth with that meaning because, again, the square root is an inverse operation to squaring. The square root is an inverse operation to squaring. So when we are finding a square root, we start with a number, we can square it, and then we take its square root. We should end up with the original number. Again, that's our whole definition of an inverse operation. Taking the square root undoes squaring a number. But it's a little more complicated than that. So here's the complication. We know that 4 squared equals 16, but we also know that negative 4 squared equals 16. So if I take the square root of 16, is the answer 4 or is it negative 4? Well, both answers are valid. Both fit the definition of squaring a number, right? Negative 4 squared is equal to negative 4 times negative 4, which equals 16. And 4 squared is equal to 4 times 4, which is also equal to 16. So since the goal is to get back where we started with when we take the square root, either answer could be correct, a positive 4 or a negative 4. We didn't have this problem with subtraction or division since there was only one answer in those cases when we were looking for that inverse operation of addition and multiplication. So here we have our first complication. When we square a number, we eliminate any information about whether the original number was negative or positive, right? We have 4 squared is equal to negative 4 squared. Taking the square root can't recover that information. Later, we'll learn how to use the context of the problem to determine whether to use the negative or positive square root, or both in some cases. But for now, we just don't have enough information. To account for both possible answers, we will use the following convention. So we will note that the positive square root will just be that radical symbol with nothing on the outside of it. So for example, when we say radical 16, the square root of 16, we're referring to the positive root, so that would be 4. So if we want the negative square root, we are going to put a negative sign or the negative symbol outside of the radical symbol. So when we say negative square root of 16, that is then going to indicate the negative square root, so that would be negative 4. Now if we want both, outside of the radical symbol, we're going to put the plus or minus symbol. That will tell us to do the positive and negative square roots. So plus or minus the square root of 16 is equal to plus or minus 4. That would indicate both answers. Now the positive square root is special. This is called the principal square root. So if you just see the square root symbol, that's the positive or the principal square root. So the square root of 16 equals 4. 4 is the principal square root. When solving problems, you will need to use the context to determine which is appropriate. But when writing numbers, it's clear the square root of 16 is a positive 4 because, again, there's no sign on the outside, so we assume it's that principal.